Okay, so we're going to start by going over 5-7, which is the first part of what your quiz is going to be over. And for number 1, that was your warm-up where you're graphing the function, identifying the domain and range, and the table was kind of started for you. So like the 2 and the 3, when you plug in the 2, you got 0. The square root of 0 is 0, so then the point that you would plot would be 2, 0. When you plugged in 3, 3 minus 1 was the square root of 1, which was 1, so it would be 3, 1. Then when you got here, you had to choose what value to plug in. So like I chose 6, Gabe chose 6, Grace was thinking 6, right? Because Grace, what happens when you plug in 6? Good. So, and what's special about 4? Yeah, it's a perfect square root, right? The square root of 4 is going to be 2. So, like, Gabe, how did you decide to plug in 6? Like, is there something special that you did? Or did you think, oh, 6 minus 2 is going to be 4?
Yeah, that's what I thought.
Okay, another way you could think of it is see how this is x minus 2? Everybody?
Yeah.
Okay, so then if you were to set that equal to 4, if you were to solve, you would do what to both sides? Add 2. So 4 plus 2 is going to be 6. Now the next perfect square after 4 is what?
9.
9. So I could just do what to 9?
Add 2.
Yeah, add 2. So then I plugged in 11. Okay, so then I was able to get really nice values. Now, technically you could still plug in 4, right? You would just have to do the square root of 2, and that would be a decimal. That would be okay.
When we do the domain and stuff, where does this 2 come from? Oh, wait, no.
Yeah, so let's talk about that. When you do the domain, okay, the domain you want to look out for any restrictions. Because this is a square root, you can't take the square root of what kind of numbers? Negative, okay? So you can't take the square root of negative numbers. So then we set the radicand greater than or equal to 0. Okay, so look at what's underneath the radical, x minus 2. So that has to be greater than or equal to 0 because it can't be negative, and then we're just solving that for 2. And then we're going to look at the range. So the range, when I'm looking at this, I want to look and see where my lowest y value is and then where my highest y value is. So can you guys see, like here is where my lowest y value is?
Yeah.
Here, this is where you have 0. And then see how the arrow is going to keep going? That means it's going to be going up to what value? Infinity. So when it's going from 0 to infinity, we say y is greater than or equal to 0. Okay, so then on the back, this is exactly what it's going to look like on your quiz. Oh yeah, go ahead, Arun.
Is the domain always going to be the radical?
Anytime it is an even root, so anytime it's a square root or like a fourth root, the one that's on your quiz is either going to be a square root or a cube root. So if it's a cube root, can you take the cube root of a negative number?
No. Yes.
Yeah, because what's like the cube root of negative 8?
2.
Close.
Negative 2.
Negative 2, because negative 2 times negative 2 times negative 2 is negative 8. So if it's odd, it's okay. And then what's your domain for every single odd root?
All real numbers.
Yeah, so the domain for odd roots is going to be all real numbers, which we're going to see. Okay, so like I said, these questions are going to be exactly the setup of how it's going to look on your quiz. So using the graph of y equals the square root of x as a guide, describe the transformations. So if we're going to describe the transformations, we need to look and see, hey, what extra is added here? Okay, so for describing the transformations, so can you guys see that now I have a negative?
Yeah.
Okay, so that's one of the transformations. I'm just going to highlight that as that's one of the transformations that we saw. We also now have the 1/2 in front, so that's another transformation. And there's one more, and that's the what?
+3.
Yeah, the +3. So can you guys see how if I took away all those highlighted portions, I would be left with this? So that's how you can tell what transformations you have. So because this is on the outside, The negative, think XO, XO. It's over the x-axis if it's on the outside. This is a vertical stretch by a factor of 1/2. Oh, not stretch. It should be a vertical what? Vertical compression. And you made me change it. Yeah, so Taylor, why is it a compression?
I just assumed.
But what tells you that?
The 1/2.
Yeah, the 1/2. So anytime it's less than 1 and bigger than 0, then you know that it's going to be the compression. So the compression of 1/2. And it is vertical because, again, it's on the outside. If it was inside with the X, do you guys? Yeah, good, horizontal. And then the +3 is on the outside, so that would be up. What if the +3 was underneath the radical? Yes, good, very good. Okay, so then for my table, for this one, this was actually nice because see how all I have underneath the radical is X?
Yeah.
So then all I had to do is use my perfect squares, 0, 1, 4, 9. So I plug in 0 and I wrote my work over here. So negative 1/2 times the square root of 0 plus 3. So this would be 0 plus 3, which is 3. Wait, you said you had what? 0? No, that's not wrong. That's fine. Yeah, that's fine. Yeah, let's add 16 together. So if we kept going and we did 16, it'd be negative 1/2 square root of 16 plus 3. And what is the square root of 16? 4. So negative 1/2 times 4 is what? Negative 2. Negative 2 plus 3 is 1. Okay, so my graph only went to 10, but if I kept going, right, 11, 12, 13, 14, 15, 16, then I would graph that there, and then yes, that would continue on. Oh, okay, so then let's look and see how you're doing that. So when you plug in like 9, right, it's negative 1/2 times 9. So the square root of 9 is what?
3.
So 3 times negative 1/2 is negative 3/2, right?
Yeah. Wait, I did. I'm pretty sure I did. So 3 from the square root of 9, and then I added 3, which is 6. I did half of 6.
Oh, okay, so you just have to follow your order of operations.
Actually, this isn't even right because it means
Yeah, so before you can add the 3, you're going to have to multiply those together. Yep, so just follow your order of operations, so multiply before you add. Okay, and then your domain, because this is a square root, square roots cannot, you cannot take the square root of a negative, so you're going to set the radicand greater than or equal to 0. And you're always going to do that for the square root. And this was nice because there were no other numbers. Okay, so if it's a square root, it's always the radicand is greater than or equal to 0. And Hunter, what does radicand mean? When I say radicand, like where is that? Uh-huh, yeah. Anybody want to finish it? Yeah. Yeah, so whatever's underneath the radical, that's just going to be greater than or equal to 0. Okay? Now, for the cube root, again, I'll do the highlighting where you can see the extra things that were put in here. Okay? And notice that this one, it says make a table with at least 5 points. The one before that said at least 4 points. And then I also have this +1 here. Okay, so the 2 on the outside is a vertical stretch by a factor of 2. And then this would be a translation of 1 unit to the left. Now, because this is a cube root, your domain and your range is going to be all real numbers. And this is for a cube root. Okay, the cube root is always going to be all real numbers. Okay, for both of them. All right, now for my table, think of your perfect cubes. Your perfect cubes are 0, 1, 8, -1, and -8, correct? But look, I have x plus 1 here. So if I have x plus 1, if I were to set x plus 1 equal to -8, really what would I do to both sides? I would subtract 1, right? Okay, so I'm getting this from your perfect cubes. Do you guys know that your perfect cubes that we've been using are -8, -1, 0, 1, and 8? Does that sound familiar?
Yeah.
Okay, so remember, if you set x plus 1 equal to 0, whatever's underneath there, you would subtract 1 from both sides. This is what's going to be in the middle. Okay, so this is how I knew I was going to plug in -1 right in the middle. So you can always subtract 1. -8 minus 1 is -9. -1 minus 1 is -2. So then when you substitute that into the equation, -9 plus 1 is -8. What's the cube root of -8? -2. So -2 times 2 is -4. This would be -1 times 2, which is -2. This would be 0 times 2, which is 0. 1 times 2, which is 2. 2 times 2, which is 4. Okay, and then remember how I showed you that you can curve these through? So after I plotted these 3 points, I actually graphed this part first. So this is what I did. I did 1, 2, 3, and then I curved it this way. And then I did 1, 2, 3, and then I'm curving this way. It's actually, do you guys remember what the cubic function looks like? Because it looks like that. So it's the same thing, but it's just turned. Okay, what questions do you guys have for me on this?
Go back up to 1.